Vasudev, thank you for your time. We are here in Phoenix for Intel Vision 2024. Thanks for your time, Vasudev. We'll talk about AI,
Right.
of course.
Yeah.
We'll talk about Intel and AI and what you are doing as leading artificial intelligence for Intel research labs. I have a huge amount of questions that come to my mind when I read what you've done. And can you start by telling us who you are and what you're doing at Intel?
Yes. So first, thank you for having me here. I think this is really exciting. Intel Vision, we are hearing about AI everywhere here. And I'm Vasudev Lal. I'm a principal AI research scientist at Intel Labs, where I lead a team called Cognitive AI. And this is a team that really focuses on how we can get to higher machine cognition in artificial systems. We especially named this team Cognitive AI about 4 years ago because we wanted to distinguish between use cases of AI in perception. So let's say you want to detect an image of a cat, or you want to detect sentiment of a sentence. So these are tasks that I would call perception tasks, and these were really hard in the previous decade. Just detecting cats was actually really hard 10 years ago, but because of the rapid capability improvements in AI systems, these perception tasks have become really good. So now for this decade, we really want to focus on these cognitive tasks, tasks that require much higher level of understanding and reasoning capabilities, and this is why we call our team Cognitive AI. So I'm really excited to be here and to be talking to you.
Thank you. So what we call cognitive, and especially I'm thinking of the managers and CEOs
Right.
watching us now. How can they use cognitive in their company? What is?
So I think a very big goal is that we can get insights from using these models, right? So we want these models to be able to find patterns in the data that we otherwise cannot, or understand a business situation from that perspective, where it can really be very insightful. So that's how I think some of the values in the enterprise can be unlocked by using systems that are going beyond just retrieving or searching for the right result, but being able to contextualize all the information and be able to get insights into it. So in some way, it's like as humans we are highly contextual, right? Like we really understand the context of this situation, right? Like we are at Intel Vision, we are here for talking about AI and so on, right? So it's setting us some expectations of what to expect and so on. So as humans, we are really contextual beings, and this is our goal, that we can make AI systems that are highly contextual. They can understand an organization's data. They can be used for extracting the right amount of insights from this data.
Very interesting. So if I understand well, it's about moving one step further from what we see in AI currently in businesses where AI doesn't understand the context, the nuances, getting to the next level where AI can understand more.
Yes, definitely.
And then bring more insight and more value to the company.
Yep. And I think, we've been in this, we've seen like amazing growth in AI capabilities over the last few years. So I think we are, it's a continuum, it's a journey, and I think that's the way the field is progressing. And of course, with all the improvements, there are also a lot of challenges also, right? So just a few challenges, LLMs, for example, still hallucinate.
So large language models,
large language models, they still hallucinate. For them to be used in a business setting, it's not good enough for them to be right 80% of the time, right? Like they have to be right, upwards of like 98, 99% of the time. So I think there are a lot of open challenges, making sure that these models are they are fair, they're ethically trained and so on. So there are a lot of open challenges around these models. But to me, it's really exciting to see how this capability has really gone from research to production, and now it's at the point where it can really positively impact many businesses and the lives of people who actually use this kind of technology.
So you talked about those challenges that most of the companies are facing today,
Right.
and one of the overarching challenge that all companies are facing is scaling.
Right, right.
Bringing more value through those use cases with AI.
Yeah.
In your view and your experience, what have you seen making the difference?
Yeah, so I think one of the most important parts of applying AI in a business setting is defining the problem statement.
Yes.
Figuring out exactly, what is it that we want an AI system to do? What kind of a data set can be curated to either use that data set in either training the model or in other forms where the model can be customized in that data, and then executing on it, deploying it at scale. And so I think it's been shown that there's been a very small fraction of AI projects that actually have resulted in businesses improving their bottom line so far. And I think a big part of that reason is conceptualizing the right problem to go after with the right kind of AI system. So I think that is one of the biggest challenges. Second challenge I would say is cost. That when you actually want to develop a system, I think one of the biggest factors is that can it be deployed in a cost-efficient manner? Or are you going to, to deploy it, the value that you're going to finally extract is going to be larger than, let's say, the value in all the compute that you're going to spend to try to deploy, and all the AI talent that you are going to spend on trying to deploy that solution. So in my mind, those are the two big challenges that people should be aware of. But I think if the right problem statement is agreed upon by the right stakeholders, then AI and machine learning techniques they can have an outsized impact on improving many processes in businesses today.
Excellent. And from reading the work that you've done, you're bringing to the world currently something that solves those issues in a way.
Right.
And this is called RAG.
Yes. Yeah.
RAG. Can you tell us about that?
Yeah. So Retrieval Augmented Generation, is a technique by which LLMs, large language models, can be customized to an organization's own data. And I would say it's one of the most powerful techniques today of deploying LLMs in a real world scenario. So let's say if your organization has their own data, which of course, every organization will have, their own white papers, documents that pertain to how that organization works. You are really interested then to figure out how can an LLM be customized to your own data. And Retrieval Augmented Generation would be one of the easiest way where you can customize an LLM to your own data set.
So just to make it very clear, the image that I like to give is training a ChatGPT-like to the data of your company. For example, you give it your annual reports, your strategy documents, you name it, your product document, marketing document. You give it everything, so that this ChatGPT got in its mind anything concerning your company. So it means you can ask, what did we do 5 years ago to unlock this market? It's going to tell you. If you ask it the question, can we launch this kind of campaign now? It's going to tell you, you could do that, but be careful. 2 years ago you tried to do that. These were the issues, so make sure that this is. So that it's really about having kind of a super intelligent co-worker or board member who knows everything about the company and can answer anything.
Yeah, so I think those are really excellent examples, and I think they are very good examples of how these situations where retrieval augmented models can customize the output of an LLM. And in fact, some of these have been situations where we've done something very similar because at Intel, as you can imagine, we have a lot of meeting notes, documents that track the progress of projects, and we've actually done this. We've taken these documents, we've ingested them into vector databases, and then we've just simply used an LLM that can retrieve information from these databases and ground the output of LLM into these specific documents. And the beauty is that you might not even need to train the model, because training the model is computationally expensive. It is of course something that many people would like to do, but the beauty of RAG is that you don't even need to actually train the model. You can pick up off-the-shelf models. You can take your own documents, ingest your documents into a vector database, and then couple that vector database to an open-sourced LLM, and this whole system can basically customizes an LLM to your own data set without spending money on trying to train the model. So I think that
And you can keep it updated.
you can keep it updated
easily.
Yeah, because training the model on new data is expensive, but taking new data and ingesting it into such a vector data store is actually quite cheap. And in my mind, this is the best possible way to bring fresh information into a model's working memory. And in any real world business enterprise, information is always going to get changed, right? Like from one day to the
dynamic.
other. It's dynamic.
Yeah.
So it's just not possible that you fine tune a model on data sets that have been frozen in time, but then the very next day that information is going to be stale, and so that model is going to be stale. So I think from that perspective, this is actually a very, very powerful technique.
So RAG solves almost all the issues that you mentioned at the beginning. You were talking about the costs,
Yeah.
the important cost of
Right.
implementing AI.
Right.
This is, as you said just now, much lower
Much
with
lower
RAG.
than RAG. Yeah. Much lower in RAG. Yeah.
The time that it takes
Right.
is also
Yeah.
shortened.
Yeah. Yeah. You might not need all the, you don't need a lot of data science expertise also, I would say, because you're not going to be retraining models. So these are things that software developers, existing talent can very easily
That's an
accomplish.
important point.
Yeah, because their AI talent is in very short supply right now. So I think this is also one very big factor. Another really big factor is that we really do want to have source attribution in models, right? So let's say you have a model and you want to get insights as to let's say what your quarterly sales were, or what were some factors that influenced your quarterly sales. So not only do you want the final response from the model, but ideally you want that model to be able to give you citations, references, that these are the exact documents that's leading to this particular output from your model.
Got it.
And
So
this
the
is
insights and the insight that is given by the model
Yeah.
can be explained by the model,
exactly
giving the sources of the information
Yep.
it is using.
Yep.
So that's a very important point, because we mentioned the fairness of those models.
Right.
We mentioned all the
source
ethical
attribution.
issues, but the
Yeah.
explainability is
Yeah.
another
Yeah.
critical component that helps us as humans to rely on the insight that is
Exactly.
given by the model.
Exactly, because like I mentioned, hallucination is a big problem in
Exactly.
LLMs, right? So to better gain confidence that the model is right, having a system where you can actually inspect the retrieved documents that are being used by the model to come up with a certain inference about the situation, I think that can really get more trust that yes, that these models are actually doing the right thing.
I love what you say. I mean, trust, I think, is a key word currently in companies.
Right.
Not only we want those models to give our colleagues, the people who are using it in the business, trust in the outcome that we got from those systems.
Right.
But we want also, when those systems connect with the clients,
Yeah.
and other partners of the company, be able to get this trust as well.
Right.
That's
Yeah.
critical.
Yeah. I think so. So I think this is why if you walk around the Intel Vision exhibition hall right now, you will actually see many rack demos. So there's a rack demo from my team itself, but you will see that there are many rack demos because as a company we realized that how powerful this framework of RAG coupled with LLMs is. It can work on client, because the compute power sometimes is, it can power these LLMs that can work just on, let's say Meteor Lake based AI PCs. And we also have demos on Gaudi 2 that are RAG demos. So I think it's a very versatile framework of introducing new knowledge in a model, of getting source attribution in the model, and being able to make sure that there is more up-to-date information that the model has access to.
Excellent. You mentioned just now that here on the show floor we will see many different RAG solutions. What makes them different and how?
Yeah. So, for example,
and it's kind of a trendy. We hear RAG everywhere currently.
So I think the compute that you're going to deploy the RAG model on is going to change the nature of that deployment. So let's say you have an assistant that you want to deploy on just an AI PC, right? Something that you can pick up, for $1,000 in Costco. So the LLM there might not be the 70 billion LLM or the 180 billion LLM that's out there, but it could be the 7 billion or even the 13 billion LLM that works pretty efficiently on laptops, and that's coupled to a vector database that has an index of, let's say, all your personal documents on the laptop, your personal videos on the laptop, and so on, right? So that solution is very customized to an AI PC, where you're not even uploading the data to a server outside. Like you don't even need an internet connection in this case, for example, right? So this will set some boundary conditions on what a RAG system can look on just a laptop. But
so you can have a RAG just on your laptop without it even being connected to the web or to a database or to a big database.
Exactly. And this RAG system can index all the files that you might want to index on your personal computer, and this can personalize an assistant just for you, for example, right? So that is an application that would run on a client on an AI PC. On the other hand, if you look at some of our demos on Gaudi 2 on RAG, you could have, let's say, a 70 billion parameter multimodal LLM, one of the most powerful open source models, and that you need an accelerator to run the LLM. You might need to ingest millions of documents. At an enterprise level, it's not uncommon to have millions of documents, and then you would deploy such a solution on Intel's data center products. So you could use Gaudi 2 and future Intel AI accelerator products for accelerating the LLM, and you could use Xeon for the databases, the vector databases, the similarity search, which is important component of this RAG system. So this is why you'll see a variety of RAG systems on the show floor here.
Got it. And all those RAG systems are using the same essential components that you mentioned now, which is the Gaudi.
So the essential systems are
the database.
Vector database, and then having an LLM. So those are the two essential components, and then depending on whether the application is on a laptop or a desktop or a data center product, how what size models could you deploy, and all that will change. But the basic architecture design of RAG is so versatile that it's agnostic to to whether it's going to be applied on a client or on a data center product.
Very, very interesting. And so we've mentioned a lot large language models, but it can be multimodal in the way.
Exactly. Yeah. So a lot of data in the world exists outside language. Like if you look at business documents, like at Intel, we make a lot of PowerPoint slides. So a lot of our business documents will have figures. They'll have tabular data. They'll have architecture diagrams and so on, and they'll also have text and
pictures, videos.
Pictures, yeah. And like if you really want to make a smart agent, like a smart AI assistant, you want that model to be able to understand all the modalities, not just language. And this is why in my team, we are really pushing for making these multimodal RAG systems where you can actually create vector databases where the embeddings are truly multimodal. So those embeddings are capturing not just the language information in the input, but this multimodal information in the input. And then you want an LLM, which is also not, LLM is like a misnomer at that point. It's not just processing language, but it can take these retrievals, which can be video segments, it can be images, and it can ground the output of the generated language in these multimodal retrievals. So yeah, I think that's a very exciting paradigm of how multimodal RAG systems can be developed.
Excellent. I don't remember if we talked about it, but that's such an important point. Those RAG models are private for the company. It's not like we would send to a public large language model confidential data.
Yeah,
it's really
So for example, the vector database, which is basically capturing all the information about your company's documents, it'll be local to your company, right? And then same way, the large language model, you can host it on private data centers and so on. So again, it's a way of making sure that you can keep confidential data within the security perimeters of your company, and ensure that if you're not comfortable, there's no data that's actually transmitted to the cloud. So I think from that perspective also, RAG is a very attractive option to deploy LLMs and customize LLMs on your own company's data.
That's very, very interesting, and I think very current. I mean, that's really something that companies should implement now and get the benefits now. It's easy to size, to grab. I guess in the AI Intel lab, you're also working on the future of AI.
Yes, yeah. So
can you give us a glimpse at what are the key directions?
Yes, yeah. So in today's world, the way large language models process images or video is also very rudimentary. You kind of just tokenize. So you take an image, you break it up into small patches, and those patches sort of act like language tokens, and they get fed into these large language models. So in my team, we are really exploring what would be more efficient ways of processing these image and video data by these same architectures that power large language models. Because as humans, for example, right, like if you're looking at a scene or you're looking at a video, you're not processing each frame independently, right? Like you're latching onto a concept. Like you're latching onto a concept of a particular person, and you're able to track what that person is doing and so on, right? So we are very interested in these kinds of object-centric representations in large language models and multimodal models, because we think that is closer to how humans reason about the world, and we're very interested in engineering similar solutions in artificial systems, that you can have these object level representations.
Yes. And this would be very important in the case of creating robots that could move in the physical space.
Right.
Have motion in
exactly. Yeah, but also this would be more.
This is in this. For this purpose that you're working on. That's correct.
But it would also be relevant. Let's say you have business documents that are talking about a certain project through different quarters, right? So having a model able to understand that there is this particular project that is being tracked through different quarters, having that conceptual understanding in the model that it's this very specific project, 2 years ago, these were basically the discussion around this project, there were certain decisions taken, and then as we progressed, this is what the outcomes were and so on. And for a model to map all of that this is all related to one project, it's something very challenging for artificial intelligence systems today. So we really are very interested in showing that this kind of concepts can be shown in large language models.
So better connecting the events,
better connecting
the consequences
exactly.
and causalities, maybe the relationship between those events.
Exactly. So like in my team, in more technical ways, like we're really interested in making sure that models understand the causal structure of the world. So they're not just relying on surface statistics, but they really do understand that if you have documents or you have a video, there is a causal structure there, and for the model to fundamentally understand that particular causal structure, because ultimately if we want the most useful insights from these models, we want them to understand that business process in that detail. So I would say that's it's a big goal in our team to get to that level of cognition in these systems. It's something that we are really excited about.
Excellent. Yeah. Excellent. Is it more or less connected to the large action models that we hear a lot about today?
I think they're connected. There are some recent trends in research also. So there are these recent trends of action of state space models. LLMs are all based on this transformer architecture, and before transformers there was this concept of RNNs and LSTMs that were used extensively. But then over the last 5 years, not a lot of people have spoken about RSTMs and LSTMs because transformers became state of the art. But now there is a little bit of revival and interest in some of the mechanisms behind RNNs and LSTMs, and that if you combine what RNNs could do with what transformers can do, you could design architectures that are even better in today's transformer models. So our team is always on the lookout for what's going to be the next deep learning architecture. Because historically we've seen that every few years there have been new deep learning architectures like ResNet, transformers, that have really changed the paradigm of the AI landscape. So we are always on the lookout that what is it now that can really disrupt the AI technology landscape today.
It's very interesting. Thanks for sharing all this. Just last question. What keeps you awake at night, so excited currently on what you do?
So I think I'm what I'm most excited about is that I get to work with my team members, who I feel like are just the most brilliant people in the world, and they're also really fun to be with. So I'm really it's just something that really excites me about the work I do. And I think the second thing that I'm really happy about, and I feel very privileged about it, is that I feel that my work is like my hobby. And for me to be able to call this my day job, I think is a privilege, because I would love to do this anyways. And the fact that I get to do this as my job is just something I feel really, really privileged about.
That's very inspiring. Thank you, Vasudev.
Thank you so much for having me.
That was a great discussion. Thanks for all the insights. And yeah, we're looking forward to hearing
Yes.
more about you.
Yeah.
You're on LinkedIn. You're
Yeah.
you're very active on LinkedIn.
Right. Yeah. Thank you for having me here. This was a fun discussion.
Thank you, Vasudev.
Yes.